Ladies and gentlemen, Asian Guy here, and today we're diving into something that could dramatically reduce your cooling costs using methods that have been proven effective for thousands of years. But instead of conspiracy theories, we're going to examine the real science behind passive cooling techniques and why understanding heat transfer principles can help you make smarter decisions about home energy efficiency. This is educational content about building science fundamentals that can actually help you reduce energy costs safely and effectively. Let me start with the basic physics that most people don't understand about how heat moves through buildings and why this knowledge can save you money. Heat transfer happens through three main mechanisms: conduction, convection, and radiation. Most people focus on air temperature, but radiant heat from the sun hitting your roof and walls often contributes more to indoor heat gain than the actual air temperature outside. This is why traditional building techniques in hot climates focused heavily on managing solar radiation rather than just air conditioning. Understanding these principles helps explain why some simple modifications can have dramatic effects on cooling costs. The reflectivity concept, also called albedo, is crucial for understanding passive cooling. Dark surfaces absorb most solar energy and convert it to heat. Light-colored surfaces reflect much of that energy back into the atmosphere. This isn't controversial science. It's basic physics that's been measured and documented extensively. A typical dark roof can reach surface temperatures of 150 to 180 degrees Fahrenheit on sunny days, while a white roof on the same day might only reach 120 to 130 degrees Fahrenheit. That 30 to 50 degrees Fahrenheit difference translates directly into less heat transfer into your building. Now let's examine legitimate techniques that can reduce cooling costs without making exaggerated claims about replacing air conditioning systems entirely. Cool roof coatings represent the most practical application of reflectivity principles for residential buildings. These are commercial products specifically designed for roof application that meet building codes and safety standards. Cool roof coatings typically increase solar reflectance from 10 to 20% for dark materials, up to 70 to 85% for high-performance coatings. This improvement can reduce roof surface temperatures by 30 to 50 degrees Fahrenheit, which reduces heat transfer into the building. Studies by Lawrence Berkeley National Laboratory have documented 10 to 40% reductions in cooling energy use from cool roof applications, depending on climate, building type, and existing roof conditions. The key difference from the exaggerated claims and popular content is that cool roofs reduce cooling loads. They don't eliminate the need for cooling systems in most climates. Proper ventilation strategies can significantly improve cooling efficiency by managing heat buildup in attic spaces and promoting air movement that enhances human comfort. Ridge vents, soffit vents, and exhaust fans can prevent attic temperatures from reaching extreme levels that force cooling systems to work harder. Good attic ventilation can reduce cooling costs by 10 to 20% in many situations. Cross-ventilation techniques use natural air movement to provide comfort even at higher indoor temperatures. Strategic window placement and operation can reduce reliance on mechanical cooling during moderate weather. Insulation improvements often provide better return on investment than surface treatments because they reduce heat transfer through all three mechanisms rather than just radiation. Proper insulation in walls, attics, and around ducts prevents cooled air from being lost and outside heat from entering. This allows cooling systems to maintain comfort using less energy. Air sealing complements insulation by preventing unconditioned air from entering the building and conditioned air from escaping. Simple weather stripping and caulking can often reduce cooling costs by 5 to 15%. Window treatments and landscaping provide additional passive cooling opportunities that don't require major building modifications. Reflective window films, exterior shades, and awnings can block solar heat gain through windows, which often represents 25 to 40% of cooling loads in residential buildings. Strategic tree placement can shade buildings during peak sun hours while allowing beneficial winter solar gain. Deciduous trees provide summer shade and winter sun access automatically. Now let's discuss the legitimate traditional techniques that inspired some of the exaggerated claims in popular content. Lime-based finishes have been used historically in hot climates because they provide good solar reflectance and can be made from local materials. These techniques work, but they require proper preparation, application, and maintenance to be effective and safe. Traditional lime plasters and whitewashes can achieve solar reflectance of 70 to 80%, which is excellent performance. However, they typically require reapplication every 1 to 3 years and may not be compatible with modern building materials or local building codes. The Mediterranean building techniques often cited in popular content work well in Mediterranean climates with dry summers and mild winters. The same techniques may not be appropriate for humid climates, areas with freeze-thaw cycles, or buildings with different construction types. Earth tone color restrictions in some HOA communities do limit the use of highly reflective roofing, but this isn't a conspiracy. It reflects aesthetic preferences, property value concerns, and sometimes legitimate technical considerations about glare and heat island effects in dense neighborhoods. Here's practical guidance for homeowners interested in reducing cooling costs through passive techniques. Start with an energy audit to identify the biggest sources of heat gain in your specific building. Professional audits cost $300 to $500, but can identify improvements with the highest return on investment. Prioritize improvements based on cost effectiveness rather than dramatic claims. Simple measures like air sealing, insulation upgrades, and programmable thermostats often provide better returns than exotic surface treatments. Consider your climate and building type when evaluating passive cooling techniques. Strategies that work well in Phoenix might be inappropriate for Miami or Minneapolis. Research local building codes and HOA restrictions before planning any exterior modifications. Many effective improvements can be made without violating codes or creating permit issues. Get multiple quotes for significant improvements like roof coatings or insulation upgrades. Professional installation often provides better long-term performance than DIY applications for complex systems. The economic analysis of passive cooling improvements should consider both upfront costs and long-term energy savings, maintenance requirements, and potential impacts on property values. Cool roof coatings typically cost $1 to $3 per square foot installed and can reduce cooling costs by 10 to 25% annually. Payback periods are usually 5 to 10 years depending on local energy costs and climate. Insulation improvements often have payback periods of 3 to 7 years and provide additional benefits like improved comfort and noise reduction. Air sealing improvements typically have payback periods of 2 to 5 years and are often the most cost-effective energy efficiency measure available. The safety considerations for passive cooling improvements are important because some traditional techniques require proper handling and application. Lime-based materials are caustic and require appropriate safety equipment, including eye protection, gloves, and respiratory protection. Improper application can cause chemical burns or respiratory irritation. Roof work of any kind involves fall hazards and should include appropriate safety equipment and techniques. Many homeowners should hire professionals for roof-related improvements. Structural modifications like adding ventilation openings should be designed by qualified professionals to avoid compromising building integrity or creating moisture problems. Advanced passive cooling techniques can provide additional energy savings for homeowners willing to invest in more comprehensive approaches. Radiant barrier installation in attics reflects heat away from living spaces and can reduce cooling costs by 5 to 10% in hot climates. Thermal mass strategies use dense materials to absorb heat during day and release it at night when temperatures are cooler. Evaporative cooling techniques can supplement air conditioning in dry climates. Swamp coolers use water evaporation and consume 75% less electricity than traditional AC, though only effective in low humidity environments. Maintenance requirements vary significantly. Cool roof coatings need cleaning every 2 to 3 years and reapplication every 10 to 15 years. Ventilation systems require annual cleaning. Window films may need replacement every 10 to 20 years. Climate-specific considerations help choose appropriate techniques. Hot, dry climates benefit from reflective surfaces and evaporative cooling. Hot, humid climates need air movement and dehumidification. Moderate climates benefit from seasonal strategies. Cost-benefit analysis should factor energy cost escalation and comfort improvements beyond direct savings. Energy-efficient improvements often provide partial return through increased property values. The environmental benefits of passive cooling extend beyond energy savings to reduced peak electricity demand and lower greenhouse gas emissions. Peak demand reduction reduces stress on electrical grids during hot weather. Heat island effect reduction provides community-wide benefits by reducing urban temperatures. Implementation strategies should prioritize cost-effective measures first. Start with air sealing and insulation. Add window treatments and ventilation. Consider cool roof coatings during maintenance, and plan landscape improvements over time. Measurement and verification helps track performance. Baseline energy monitoring provides savings data. Temperature monitoring identifies hotspots. Comfort surveys quantify subjective improvements not shown in energy bills. This is Asian Guy, and understanding real science behind passive cooling helps you make informed decisions without falling for exaggerated claims or unsafe projects. Focus on proven techniques, providing measurable benefits while ensuring safety, code compliance, and proper maintenance.